right. Well, welcome to the Tech Meetup presentation titled Search Owl. This Search Owl has been a project that I've been working on the weekends since GPT-4 came out, and I've been kind of testing it and developing. I wrote a bunch of code today and yesterday, and all the time. It's been like upgrading a lot of stuff. So I really wanted to share what I've had so far here in this project. If I were to give a one-line pitch, Search Owl is a language model assistant that interfaces with a search engine on your behalf, and can use the search engine on your behalf a lot better than if you were to use a search engine yourself directly. That's sort of the idea here. And so the agenda for the presentation is that I'll first discuss what's wrong with the search engines in terms of, sorry, 1 second, I need to start this slideshow here. I'll discuss first what's wrong with the with search engines, what are my thoughts on what's broken about search engines right now, and then I'll try to explain how my project attempts to solve some of the problems that these engines have. I'll explain how Search Owl uses Google, which it does. It's not a replacement for Google. It's an addition to Google search engine. I'll explain how Search Owl uses language models like GPT, but in theory, also other models as well. And then I'll talk about two sort of very more in-depth problems I ran into while working on this project, such as how to split large documents for consumption by a language model, and how to do contextual question answering with a language model that also turns out to be a bit tricky. So these are sort of the 5 big things, and I'll be doing demos throughout the presentation as well. All right, so to discuss the search engines, I think it's interesting to reflect on the history of the big ideas in search engines so far. And to me, this is how I look at this history. I think it all began with web directories in the early 90s, where it was just a bunch of links to other websites that you could use. Then we had first crawled indices around 94, which is where you have an actual text index of the content of other websites. So you can actually efficiently search for pages that contain correct keywords. Very useful idea. Then by 96, Google comes out with PageRank, and PageRank essentially is an addition to a crawled index. PageRank solves the problem of how do we essentially discover which of these web pages are important and relevant, in addition to the keyword match that the crawled index does. So it was very useful at the time because the internet was changing and shifting and growing. It was very important to constantly update and discover new domains and web pages. So PageRank served an excellent role at the time. And then nothing really changed since then until 2013, when Google started using semantic querying. The idea of semantic querying, if you remember, this was that instead of now searching for keywords, you can have a natural query like, how to cook some kind of a meal, and then the search engine will understand how to translate it into keywords and then do crawled index and so on. And actually, semantic querying, I think, is the last major idea in search engines. Nothing really happened since then. You might say, well, what about the language models and GPT and so on? Well, to me, I think language models and in general research into natural language processing at Google has been a continuation of the semantic querying idea. And if you think about it, the reason why Google was interested in natural language processing is exactly because they were trying to build semantic querying functionality into the engine. So in some way, you can see transformers and GPT and other sort of modern technology as sort of being an extension of this earlier idea in the search engines. But here's the twist, though. Even though semantic querying has gone far, we've gone all the way to GPT right now. PageRank has not seen any kind of upgrade since basically 96. I'm sure they do some tuning under the hood, but the big idea behind PageRank didn't change. And I'll argue that PageRank actually doesn't actually serve the current state of the internet and the user base of the internet anymore. There are serious flaws with it that actually translate into bad user experience. And the reasons why I think PageRank doesn't make sense anymore is because the internet is different from the 90s in two ways. The first one is that it's a lot more static. The internet, we don't have new Wikipedias coming out every year anymore. There's one Wikipedia, it's been around for decades. Nothing is really changing about that. So there's no reason to rediscover the page rank of Wikipedia. It's already known to be a good source. And similarly for other kind of domains, there's a lot of well-known good domains who don't actually need to be discovered in any algorithmic way. We can actually just say, well, these are the good domains, so let's just use them for a particular purpose. And the other one is that there's a lot more concentration on the internet right now. We used to have a lot of small domains all over the internet. Now we have a very sort of exponential curve. There is a few super important domains and an enormous giant tail of very not important domains. And the result is that PageRank doesn't help us with that, is because it actually, yeah, we can essentially think about this way. Like, what the question that the PageRank was trying to answer it is, what is the scope of search for your search query? So the answer that Google gives you is that if you try to search for something, it will search over literally the whole internet. But here's sort of the problem. Sometimes that may be not exactly what you want to do. Sometimes you already know what domain you would like to search at. So for example, you're looking for Python documentation and go to python.org, but there you can only search on one specific website. So you have these two extremes. You either search over the whole internet using PageRank, or you search in one particular website and only this website. I think these two extremes are too extreme. We're in the middle ground. And that's sort of the idea I have for how to improve upon PageRank, is to say, well, what about if we have a set of well-known theme-specific domains? So let's say you compile 100 domains which are super relevant for example, software engineering. And now you don't have to trust Google to rediscover these important domains every search query. You actually already know, the subset of the internet that you would like to use for your next query. That's sort of the idea I have about how PageRank doesn't kind of like work with this new reality of the internet at the moment. Does anybody feel similar in this regard? Does anyone ever feel this problem is like either search the whole internet or just one website?
I guess the one problem I feel is it seems the big innovation in search is dominating Google results with advertising. And so yeah, I find that the quality of the searches is certainly lower. And, there's all these anecdotes, like you get better searches on Reddit or on going on Medium. And I guess maybe that anecdote speaks to this slide.
Yeah, for sure. And yeah, go ahead.
I definitely search only site:/stackoverflow.com, and then I type what I actually want. And then if I forget to do that, I'll just get 10 results where the bottom 9 are just websites that have scraped Stack Overflow but repackaged it, which is annoying. So I'm like, I've already seen all this content. Why are you on the first page of Google? You just gamed their system. You're not actually providing value.
Yeah, and also to everyone's point as well, like I don't really care where it comes from. I just want the answer. And I think the site only matters insofar as that we assign a value or a reputation score depending on like Stack Overflow. We go, okay, this is probably more useful than like a random blog post. So, but I don't actually care if I get the right answer. I don't actually care where it comes from.
Yeah, you're right. You shouldn't care. It's just, yeah, unfortunately, reality is that to get good results, or at least one way to get good results is to have a well-known good list of domains. So you might think that this idea of this middle ground is something that will be the competitor to Google. What if I told you that actually Google itself provides this functionality, but you have to be a little bit more, we have to use their developer tools to get there. So Google has this product called Custom Search Engine. It's been around for a long time. It's not really very well known, but it exists. And it allows you to basically change the settings for the search engine and then use that customized search engine. So it has a web UI, I'll show it in a second. It has JSON API, that's what I will be using in Search Owl. It allows you to allow a list of domains, which is what I have done. And it supports up to 10K queries per day right now, per API token or per search engine. So I created this search engine that I call Engineer Engine. And currently it has 44 domains plus the whole .edu suffix. So basically any educational website plus 44 domains that I hand selected. So here's the first 10 domains in this list: algorithmica.org, allthingsdistributed.com, apache.org, archive.org, Ask Ubuntu, AWS Amazon.com, cloud Google.com, developer Apple.com, developer Mozilla.org, DevHints, and the edu suffix. So even this 10 domains, or 10 domains plus the edu, it already contains millions of web pages that you can potentially answer some questions with. If you ask a question about one of the themes that are covered by these domains. So I have more. I'm not showing all the domains. I'll show you later. But here how it looks like. If you this URL here is actually public. All the custom search engines are public, so you can actually use this if you want. I'll put this in chat if I can. Where is the chat?
So you're basically back to the old 1990s directory curation again, but just at a different meta level of directory curation.
Pretty much, and I wish this wasn't the case, but that's where the reality has pushed me into. Anyway, so the URL I pasted in the chat, you can open it and use it as well. It's basically looks like this. It's just literally just the search bar. And the only thing that's different is that it basically searches exclusively over the domains that I have allowed. And so here I get high quality results like Wikipedia, edu domains, GitHub, and so on. And so, for example, if you search for lawyer, you don't get like a million, offers to hire a lawyer. You get Wikipedia, edu, educational domains, and so on. So this is sort of highlights how the same queries that would not give you any of these results in Google.com gives you results that are specific to your needs in this sort of.
Why do they allow this? Like, where are the ads? How are they, is this not a threat to their own business having this available? Like, this is a better version of their own product, but without advertising.
I think you will see ads. I don't see ads because I'm the owner of this of this customized search engine. I think when I open this in incognito mode, I get ads. So you'll see ads, but yeah. Anyway, I'm just showing this just because to show you this exists, right? I'm using the JSON API, so I don't even care about the ads anyway, because I'm using this in a different fashion. Anyway, I'm using the JSON API for the search. Anyway, so regardless of that, I think this is actually pretty cool as a replacement for Google.com to start with. I think this is already an improvement. Though, again, because of the limitations, the number of queries per day and the ad situation, like if you really want to invest in this route, I would recommend to like create your own custom search engine and like upload your own list of domains that you like and so on. Anyway, let's move on because we need time. So the search algorithm basically is built around this custom search engine. And the idea is that the Search Owl will interact with this custom search engine on your behalf. So you, the user, ask a question, and then the LLM suggests search queries that it wants to try based on your question. Then the search queries go to Google. Google returns the links, for 10 links per search query. Then LLM looks at all those links and URLs and snippets from those links and chooses 3 or some other number of links that it would like to read. So snippets are short, like 100 characters, but then the LLM selects which links to look at. And then for each of those links, we actually do a full read of the web page. So for each link, I fetch the HTML or the PDF file, depending on the link. I create tree-aware text chunks, and I'll explain what these tree-aware text chunks are from HTML or PDF. Then LLM selects top chunks by embedding similarity. Again, we cannot really read the whole page because it's maybe too big, but we use embeddings to pick which chunks are relevant to the user question. And finally, LLM summarizes the chosen chunks of text to answer the question. So this is sort of the flow. You ask a question, it Googles for you, looks at the links, picks a few links, and then picks chunks of the web pages that it would like to really read in detail to understand how to answer your question. So in theory, it kind of basically can read and summarize, text maybe like 100x faster than you can. So it should be able to pull information faster than if you were to like manually go through the links. And so this algorithm here reflects this what I think is like this information retrieval funnel, which is at the top here we have a lot of data of Google search index, enormous amounts of data, too much to read with an LLM or something. But we use search index because it's a very fast and compute efficient and cheap way to find documents which are relevant to a query. And then from there, we can use embeddings, which cannot process as much data as the original search index, but some section of the search index, like tab 10 pages or something, we can run embeddings on to then narrow down even further the scope of what we think where the answer is. And then finally, the third stage is language generation, where we give LLM the actual text of the selected chunks of the web pages and ask it to summarize them. So this sort of goes from a lot of data to less data, but also from very cheap to very expensive. The difference here is like 1000x in terms of cost per byte. It costs 1000x or more to process a byte of text with the language model than with a search index. So it's very important to like reduce the funnel as much as possible at the right place, so you can then overall have efficient information retrieval that's not too expensive per query. So right now I'll show the details, but right now I'm aiming for 30 cents per query is my current target. And this is mostly price for the language embeddings and language generation, essentially. I think this is the demo time, or the first demo. So search query plus rank. Yeah, we'll do it step by step. So let's start with the search query selection. So here I have, this is the web app that is basically the developer version of the Discord bot that's available in Discord as well. It just allows me to do a few things, including introspect the like intermediate steps in the processing. So here, for example, I'm just looking at the query suggestion. So my question is, how does enumerate function work in Python? So the LLM prompt for this case is like this. You are a search engine query suggestion API named Search Owl that can find relevant search engine queries. You always reply with a JSON object with a queries key and a list of three strings as the value. The list must contain the search engine queries that are relevant to the user's question. You must not include any text except for the JSON object. And then I have two examples here. Example one, user question in a JSON object, and then the search owl's expected reply in a JSON object. The reason it's in a JSON object is because we need to parse the output of the LLM's response. So we need to be very specific about how to reply to our prompt. So I give two examples to show basically what does it mean to translate a user question into search queries. And then the user message here is also a JSON object, and this is our question we were originally asking. And the response from the LLM is now a JSON object as well as a queries key, and it suggested 3 search queries: Python enumerate function explanation, enumerate function tutorial, and how to use enumerate in Python. And these are now the search queries which we can use with the search engine. Okay, then after this, the next step is ranking the links. So let's say actually, let me copy one of the previous responses. So let's say we copy this first query here. I copy it here. So now essentially we can run this query against Google, but what we'd like to do is we'd like the LLM to rank the links, because we don't want to read all of them, or we're not sure that the top link is actually the best one. So here I have a second different prompt where I'm saying, okay, you're a search owl, we'll have JSON encoded messages. So basically, we would like the task is to read the list of link options and to rank the snippets from 0 to 9, 0 being very important, 9 being not important, according to the relevance to the user's question. So we're basically asking the LLM to rank the links. And the links here are basically things that came from Google. So here I had the query Python enumerate function explanation. The links here are basically what Google search engine has returned. The title of the page, the URL, and the snippet. So this is all we have about this web page at the moment. And basically the idea is that LLM can look at the title, at the link, at the small snippet, and determine, is this relevant to the question or is it not relevant to the question? So we'll give it 30 or how many? No, just 10 in this case. We give it 10 links and ask, and it gives back this object here, which contains the index of the original link and then the rank that it thinks how important this link is to the query. So this way we basically construct the ranks for every search result that we got from Google. Sometimes these things align, sometimes the search engine and the LLM disagree. So here's an example. We had this web page here from Python documentation. The search rank was 4, but LLM rank is 0. So the language model thought that this is actually a very relevant link, and so on. So we can see basically the search, just for now, just the search results without the content of those web pages. But now we at least understand which of these web pages we think are relevant based on what the language model thinks. Cool. There's no questions. Let's move on to the next part of the algorithm. So splitting. So this is the actually kind of the hard part here. The thing is that if we look at one of these web pages, we'll see that it's actually enormous. It's like maybe like 100 kilobytes, 50 kilobytes, definitely too much to process in one go for a language model. So we need some kind of a splitting algorithm. And so basically what's nice about HTML web pages is that actually there are trees which have depth. I found this cool tool in the Edge browser, which allows you to see the 3D structure of a web page. So here I have this GPT-4 Wikipedia page. On the right is this interesting visualization that Edge browser has for showing you the depth of the page according to the HTML structure. So as you can see here, the web page in the HTML format, it's not a flat. It has this tree structure that has depth. And it's useful because we can actually then use this implied structure in HTML to figure out how to split the web page into sections that are small enough to be processed with the language model. So this is very useful for this use case. So let's say now I'm going to show you a simple example. Let's say I have a HTML document like that has like HTML tag here, has a header, a body, and a few small tags, h1, h2, article, and div. And our window length is 10, but the document is 20. So we need to split the document in at least 2 chunks. And so if you were to go with a text-based split, you would get something like this. You get the first chunk here from 10 characters, and then another chunk here, 10 more characters. The problem with this split is that it basically creates, it splits the article in half, which is going to be very bad because potentially you're kind of ruining the summarization ability of the model because it doesn't see the article in full. It only can see half of it at a time, even though the article is small enough to fit into a single prompt context length. So splitting by text or by size of by text like this isn't really good. What we want to do is we want to do a tree-based split. And this is the algorithm that I sort of developed for this purpose here. The idea is so that we're going to be doing top to bottom splitting first as much as possible, and then we're going to do left to right binning. So what it means is that here we have, remember the context length is 10. We need to have chunks at most of size 10. So we're going to start with HTML tag. Oh, okay, it's too large, need to split. So now we have 2 tags, head of 2 and body of 18. Okay, 18 is too, head is small enough, that's fine, but body is too big, it's 18. We have to split one more level. So now we have h1, h2, article 8, and div 6. Okay, now we have small enough chunks, and by the way, we don't have to split article. Notice the difference here, because article is small enough, we don't actually need to split it further at all. We keep it as a single tag here. And then now we do left to right binning, where we say, okay, let's basically combine H1 and H2 into one chunk. Then article can be its own chunk because it's just almost the right size. And then div6 will be the third chunk. And so in this way, we're able to split the HTML document along the edges of the tree. And that preserves important structure, like the fact that we didn't split the article into half. And so this is sort of a way to improve document splitting into multiple chunks.
Is this dependent on like website specific? Like you have to know you're dealing with the Wikipedia structure as opposed to the Stack Overflow structure, and then tune it to discard the way that each site does their nav bar, for example?
Yeah, no, I mean, it could be improved to be website specific. I found that this works just fine in most cases. Most websites have enough tree depth that you can find natural edges along which to split the document without sort of too much problems. Yeah. So one more way to split the document is using Markdown. So this is actually something I found implementation in LangChain. I'm sure you've heard of the LangChain library. So it has a bunch of functionality. One of them is Markdown splits. They actually use another different approach where it's similar, but it's different. So what they do is they have this list of separators from the top level header to lower level header to subheader and so on. And they basically try to split in this order of these separators, and that sort of implies top to bottom split. So it's almost the same algorithm that I was using, except that they implemented it differently and for Markdown as opposed to HTML. Yeah. So yeah, let me download the splitting now. So that's oh man, do we have to do live debugging?
Hey, we did it on the episode where you had your friend speak. So
let's see, text splitter. This is in the LangChain. What? Oh, I didn't pass text. Let's just do HTML split then. Yeah, that's fine. We'll see if we don't have to fix it later. Anyway, so I have this URL here. It's just, I'll open what this is. This is documentation for Python. And it basically is the bunch of documentation for different functions. And each function documentation is actually a separate HTML section. So HTML splitter will understand that the boundaries are between functions here. And so if we set the max length to 4,000 characters and use the HTML splitter, the results we get, we have a document with 75,000 characters split into 21 chunks, and chunks of different size. So in this case, some of them are smaller than 4,000, others are larger than 4,000. But the results is that basically we have this. Oh yeah, one thing I also then convert the individual HTML chunks into Markdown. So when I render them here, you can see actual like headers and so on in Markdown format. So in particular, if you look at some chunks here, we will see that the splits are always make sense. So here we have a chunk that starts with the new function definition, and it ends with the end of some other function definition. The next chunk starts at the next function definition. So you'll see that the chunk boundaries preserve the inherent sort of structure of the document and don't split things where they're not supposed to be split. So that definitely sort of works pretty well in this case, where we have this sort of like natural separation of the web page into many different components. Yeah, it's very Markdown split. Well, let's hope it's actually. Let's try a different URL there. Well, I doubt it's going to work. Yeah, well, I'm not gonna do live debugging. I do have I can roll back, I think, to previous version. Give me a second.
LangChain is really cool, by the way. I've been playing with it myself, and huge interest at Rand for using it for all kinds of things, like the map reduce summarization method is pretty cool for summarizing like 100-page documents. It's got like, that library is exponential right now, and deservedly so, in my opinion. It's doing a lot of cool stuff.
I'm gonna have a Swift library for you guys pretty soon. It's in progress.
Nice.
Yeah, actually, I'm not sure what broke the Markdown splitter. I'll take a look later. Hopefully, it will not be a problem for some time. Let's go back to the presentation. So I demoed splitting. So basically, yeah, I have either HTML splitting or Markdown splitting. I use Markdown splitting for PDFs, and the Markdown splitting for PDFs and HTML splitting for HTML documents. So that's why I need two of them, is because obviously PDFs do not have any HTML in them.
Wait, how do you do that? I literally wrote down that as a note because I need that for what I'm doing at work right now, to convert a PDF into the structured hierarchy. And like,
Oh.
how
Yeah,
do
I'll show you.
is there like a library you're using?
Yeah, so for HTML, I use Pandoc. This is a library that can convert a bunch of different formats to each other. HTML, Jupyter notebooks, all kinds of LaTeX, Markdown. It does have PDF, but it can only convert to PDFs, not from PDFs. So that's where I had to do something else. For PDF, I'm using this JavaScript library called PDF2MD, which is a specifically PDF to Markdown conversion. Yeah, it's not as...
You have to have OCR first, right? I assume.
Yes, PDF has to be already structured. It doesn't do OCR. It's the PDF that's not scanned. It's the PDF that has actual text in it.
Oh, yeah. All right. I'm dealing with like old PDFs. So
Then you have to do OCR. That's different from this. Yeah. No, I mean,
Okay.
the PDFs here that I had in mind were like for example, from archive.org, right? So when you get the PDF here, this is not scanned from paper. This is like converted from LaTeX or something. So if I take this URL here and plug it here, it will use this PDF2MD library to give me Markdown for this PDF document without any OCR. Oh man, it's a big paper. I forgot. Anyway, yeah. So that's, you get the Markdown with all the text and stuff like that. Anyway, so back to presentation. Yeah, contextual QA. So we have not too much time left. I did want to. Yeah, maybe I'll skip. I have a few thoughts here. I have quite a few thoughts on contextual QA, but I'll skip that and I'll just show you the prompt. Compressed chunk. So let's say that we have, my original question was, how does enumerate function work in Python? And we found this chunk here, so there's some text that describes how enumerate function works, an example and some other Python example. If we wanted to have the LLM answer the question about this chunk, you would think it's easy, but it's not. And unfortunately, a language model it's very eager to ignore your text and just to answer the question from its own knowledge. Yeah, so it's actually requires some very kind of careful tuning to make the language model answer the question faithfully to the context. So here's my prompt. Read the given text from the author and answer the corresponding question. Use Markdown syntax for blocks like code, quotes, formatting. Make sure that all formulas are wrapped into backticks. Answer the question from the author's opinion based on the given text. Reply with no opinion if the author's text does not have an opinion about the question. So this is very important. This language here, it might seem arbitrary, but this is me trying a bunch of different things and reading papers on this topic. And basically what I discovered is that you want to set up the instructions such that you sort of telling the model to answer the question. You want to tell the model to talk about the author's opinion about the question based on the author's text. So, and then you also want to give the model an option to tell you that there is no opinion in the author's text about the question, because sometimes you'll get chunks which are unrelated to the question, and you want to make sure that the model rejects such chunks. So here, these are the instructions, and the question is the one we wanted to ask. The text, author text here is what we have seen before this. This is also a JSON object again. And then the LM response here is a markdown with information about the enumerate function. If I give it a chunk of text that doesn't, I guess let's try a live demo. If we give it an incorrect prompt. Now, see, this is exactly what I meant. Sometimes it doesn't actually work. And because, wait, did it apply? Or did it not apply? Oh yeah, here we go. Here, so it reran this prompt with a chunk that has no information about enumerate function, and it gave me back no opinion. And in Python, I search for the no opinion string, and if I find it, I basically throw away the chunk because I now know that it's not actually relevant to the question. Cool. So finally, to put this all together, well, not exactly. So the final step here is basically a full page summary. So we've gone through all these different steps. So here again, I have this kind of like intermediate step where I take one URL, just one URL that we have seen with Python documentation. I'm still using the how does enumerate function work in Python question. I would like to summarize 3 chunks by highest embedding score. So I kind of glossed over the embedding similarity, but I'm sure you can find information about that. I'm basically selecting chunks. Out of 22 chunks on this web page, I would like to just look at 3 because it's very expensive to look at all the chunks again. And I'm using Markdown Splitter. So we have selected 3 chunks. The first one, the model said no opinion because there's nothing here about the enumerate function that we are looking for. The second chunk, it actually does contain documentation on the enumerate function, and that's where for this chunk the model returned back the summary about the enumerate function in Python. And the third chunk is again irrelevant, so it returned no opinion. And then finally, I do one more sort of pass over the summaries of each chunk to produce one single answer for the original question. And that's how I summarized a single page into an answer to the question. Cool. I mean, if there's no questions here, we'll just look at the whole thing end to end now, since we've gone through all the steps. So basically, yeah, I mean, we're basically going to ask a question. I have a few pre-computed questions. What is GPT-4? So here, actually, I'm going to provide one more thing, which is what I call a basic answer. The basic answer is GPT's answer without any context. This is basically without accessing the search engine. It's kind of useful just to compare the results. So here, the model knows today's date, and it claims that there is no GPT-4 released yet, because this is answer from GPT 3.5. It doesn't know about GPT-4. So it says it doesn't exist. But when we go to the search engine, Search Owl will creates 3 search queries: GPT-4 release date, GPT-4 features, GPT-4 with a GPT-3 comparison. Then it looks at Google search outputs and picks 3 links to look at: OpenAI page, Wikipedia, OpenAI page. And then we get from the in-contextual answers for each of those 3 links. The language model read some chunks from that web page and gave us a summary about what GPT-4 is and what does this page says about this GPT-4. And similarly for Wikipedia and the third web page here. And so this costs us 23 cents to run right now. And that's kind of like the end-to-end sort of result here, right? We start with the question, and then we use a search engine to contextualize the answers to the question.
Daniel, you want me to get a tip jar circulating here for paying for the total cost of all the searches?
Hey, man.
Tips can be sent to adrian@electorventures.com. All proceeds will go to Danilo.
Look, here's a scary slide. This is my OpenAI bill in March. I went from zero to 200 in 3 days. So it's actually very easy to spend a lot of money on OpenAI. It's especially so. What's important to realize here is that the reason that this is valuable is because in just a few seconds, the model has processed 32 times 4, approximately 100 kilobytes of text. It would take you probably an hour or so to read all of that text. So it had processed a lot more text than you would process when you're just chatting with ChatGPT in the browser. So that's why it's a lot more expensive to process data in bulk like this, than just chatting with it, one message at a time. So yeah, very important to keep prices in mind.
Are you using GPT-4 for all the generation?
So I go between. So the problem right now is GPT-4. It has it's a lot more unstable, or the API is unstable. Like I get timeouts all the time. So right now I turn back to GPT 3.5 for most of the queries.
When it's still that expensive.
Yes. And even before that, actually, I would only use GPT-4 for some parts of the processing and use GPT 3.5 in chat mode or in just a regular text completion mode, because the prices are can be expensive. Let's do a few more queries, or maybe somebody wants to recommend a query. Anyone want to volunteer? Ask something that very software engineering or programming related that you can think there is a documentation about.
I have a cliche pandas one. Well, what's the fastest way to iterate through a data frame?
Let's go on.
I've been using a competitor of yours, I think.
Oh, what's it called?
Find.
Yeah, I mean, it's fast. Are you talking about like a competitor of the search or of pandas?
Of the search, yeah.
Oh.
I think they do it similarly.
Yeah, I've seen it as well. All right, so the basic answer, it looks like it already contains. Does it actually answer the question? Avoid iteration, use vectorized operations. Yeah, it's sort of on the right track. Yeah, I mean, you could consider it could be a good enough first answer. Again, this is without the context at all. So this is something you would get from GPT 3.5 or ChatGPT web interface. So the search queries that ran: pandas data frame iteration performance, fastest way to loop through pandas data frame, vectorized operations on pandas data frame. Okay, so it selected 3 links. The first one is a Stack Overflow question: does pandas iter rows have performance issue? So the answer draft provides conflicting information about the fastest way to iterate over a data frame. It first suggests that using pandas iter tuples is generally faster than iter rows, but then contradicts itself by stating that iter rows is the fastest way. I guess people were disagreeing on Stack Overflow. Let's take a look.
You have multiple authors, but you're asking it in the viewpoint of the author. What does the author think? But you got like 20 people arguing in the comments, probably.
Dude, the Stack Overflow community is going to argue over it for 20 years while an entrepreneur uses the shittiest version to build a business.
Yeah, people were disagreeing here. So I guess the answer is a bit ambiguous, or in terms of, but it basically summarized what people were saying on Stack Overflow. That's sort of the TLDR here. Let's look more. So there is a GitHub blog, iterating over rows, pandas data frame. So they say here vectorization, using functions like apply, lapply. Other methods of iteration like loops can be slower. So pretty relevant. And again, we could open the blog page and kind of like look at the details of what the person was talking about here if we wanted to. The third link, again, Stack Overflow. What is the most efficient way to loop through data frames? The fastest way to iterate over data frame is to access underlying NumPy and the array using values, either tuples, either rows. Yeah. So yeah, I mean, that cost you 22 cents, Adrian. Please send the money.
I'll be the kind of a community participant and cover the full costs of the bill for this,
Oh,
for this
cool.
call.
Nice.
You can Venmo me $3.
Yeah, let me. I'll show you one more query that that I wanted to highlight because it's interesting. So you might have seen this Sparks of AGI paper that came out from Microsoft a few weeks ago. So obviously, the model itself has no idea what this paper is about because it has not read it. But of course, if it goes on to start searching, it will search for Spark of AGI summary review paper analysis. It finds discussion on Hacker News of this paper. It finds the actual paper. I think this is the actual paper here. Let's take a look. Oh no, this is just a reference page of the authors. Never mind. And then a Substack discussion of the paper. I'm surprised. I think it used to find PDF before. Let's take 6 links maybe or something. I'm pretty sure it used to be able to find the PDF of the paper, but maybe it's just Google search results changed or something. Hacker News, Substack. Oh, this is off topic. So is this? Yeah, no, I guess I'm kind of surprised it's can't find it anymore. Well, anyway, where is it? Where is it computing? Well, I guess even if it's just based on the discussion, just based on the review of the paper. So it's able to find this Hacker News discussion of the paper and then describes that the paper is about AGI, development of computer systems that can think and reason like a human. Paper explores the potential of AGI. Here's another summary. Summary from the reviews of the paper. So we can basically now see the results here that the base model itself doesn't know about at all. So this is sort of like the Bing chat experience. If you have tried Bing chat, it's kind of like that, except it's a sort of just like one message at a time right now. Yeah, that's pretty much it for the demo. So or the presentation, I think. So yeah, I'll take more questions, or if we can do more queries if somebody wants to suggest one.
Why don't we also give Tech Meetup round of applause to Daniel for a great presentation?
Thank you.
We all owe you
Nice.
0.00001
Yeah.
Bitcoin.
Oh yeah, we should pay in Bitcoin. That's the right energy of the meetup.
Yeah.
I put a link in chat to a GitHub repo called PaperQA, which is really interesting. It uses LangChain. It's basically like it's for academic research, but it does a lot of chaining and prompt stuff. And you basically can give it, here's a bunch of PDFs, chunk them, analyze them, do recursive summarization, all the things, and then ask your question. And then the magic thing it does is that it provides the citation. So there's like a lot of concern lately about hallucitations, like hallucinations, but citations. And it lets the human verify that the answer it gave, it even says, this is the language model answer, and this is the actual real world place where I got that information from. So you can go fact check it.
I already summarized what this package does while you were describing
There you
it.
go. Nice.
Daniel, what was your biggest learning lesson from building this? Like beyond obviously the cost, like anything that surprised you or stood out to you as unexpected, or like you didn't realize that would be the case?
I think the biggest takeaway I would say here is that there is still a lot of unsolved problems in the solution like this. So while I was like decomposing this big product into smaller problems and solving smaller problems, I realized that almost all of the solutions to the smaller problems that I came up with were sort of suboptimal heuristics and just like quick attempts to solve the problem. And I don't think we actually have like any sort of known open source solutions to those problems either. So I think there is still a lot of opportunity for people to innovate on problems like document splitting or contextual Q&A, or for how to process, HTML or PDF, or how to use a search engine with the language model. So all these sub problems still have a lot of potential for improvement. And so if like you take the performance of Search Owl right now, if somebody worked on this product, for another year, and like it would get a lot more better than this for sure. And also as a sort of community of software engineers, I think we will see a lot of improvement in the information retrieval solutions in the next year, because I don't think we have already exhausted all of the potential of language models in this problem domain. I see so many potential improvements I could do that I just don't have time for. And I think everybody in the community has the same feeling right now.
As a follow-up to that, have you seen like any reason why somebody would want to contribute their data set to ChatGPT, or I mean just their corpus to any sort of like open model?
Yeah, I mean, it's a tough question. I don't know. It's the thing is that like the question is sort of a bit ethical and legal and in some way, because like if you put your information on the internet, doesn't that imply that you want people to find your information? And isn't one of those cases search engines indexing your information? Another use case is a language model finding your information. So yeah, I don't know. It's a tough question about the society.
Okay.
At Rand, we definitely have an internal only version of OpenAI spun up in Azure that's within our network boundary, so that our researchers can send non-public data, but still use the language model the same way everybody else is. But we have guarantees that it's never going to leave our cloud boundary.
Do you guys feel like we need more public data sets to improve the models, or like do you see any holes when using these language models? Or
We're not yet on the Rand side. Like we're finding that the prompt engineering plus the base model is more than sufficient to do all the low-hanging fruit there is. I'm sure at some point we'll get to the stage where we need to do like fine-tuning, and can we discover new knowledge by sending it 1,000 Rand papers and have it synthesize some brand new thing. But right now, yeah, there's like so much low-hanging fruit, kind of like what Daniel was saying, how everyone's got their own version of improving search, and it's like a lot of commotion right now. And like things I was going to do last week, if I just waited 2 weeks, there'd be an open source package that would do it for me in a single line. Like that's kind of the phase it feels like we're at, to me at least.
Yeah, I've noticed that too. There's so many people working on this that like, I don't know. I'm curious to see like how people will build products that are defensible, because it's just like somebody will do something and then it'll be open sourced like a week later. Like somebody will see, like, the whole thing is interesting.
At 20 cents a query, like how would Google even compete with being at their scale? It would like bankrupt them immediately. Like, I don't know how they're going to address this.
Yeah, I don't know either. I obviously have to charge extra because the ads will not pay for that, obviously, unless it's like 99% ads, which would be horrible. It has to be a charge. Here's actually, it highlights a problem with OpenAI's current commercial structure, which is that basically the service provider owns the token, which pays for the queries. So if I would give you this URL and make this public, like I would be paying for your queries. The problem is that that doesn't scale to like a situation where a single service has a bunch of users, and because either you have to make the users pay to the service provider, but I think a better solution would be if every user had their own private OpenAI token, and the website could use that token on behalf of the user to spend, a few cents or whatnot. And then this way, basically, like I could just give you the URL to this website, and you could just use it all you want, and it would be like your billing account with OpenAI will be getting charged. I think it would be a much better solution to the payment problem. Because to be honest, like, is this query worth 10 cents? I would say yes. I was getting a lot of. If you look at the Discord Search Owl channel, I use this thing a lot, and I was getting a lot of value on different questions about different topics. So, like, to me, I think I would pay the cents per query that it would cost. It's just that, yeah, I wish like I could like open up this website and the user would pay for their own queries.